response to a survey that happened a while back is fabricators really seemed to have a lot of issues and questions surrounding importing CAD into the CAM system. So that's what we're going to focus on primarily. Then at the end, we're going to talk about the second most important thing in that survey, which is automation. A little bit about today's agenda is I'm going to go over a few slides telling you about SigmaNEST for those of you who are not familiar with us. We're going to go over some basic 2D import. We have some new technologies that we implemented in the latest versions. We're going to go over PDF import to include raster and vector. We're going to define them. We'll go over 3D import, focusing in on SolidWorks, but we know that with SigmaNEST we'll be able to import many of the different files from various other CAD systems out there. Siemens is one of them as well. We'll look at how those interact with PDM systems. Then we're going to look at some automation. That's pretty exciting right there. Sigmatek was founded in 1993 in Seattle by a gentleman named Ben Terra-Blanche. Shortly after he founded that in 1993, he moved to Cincinnati primarily to be in the, there's a 5-hour radius around the Cincinnati area that has, I think, 80% of the manufacturing in the US. I think what precipitated his move was some other things that's kind of legend, but that's not important to what we have going on now. We have over 250 employees worldwide. Since that time, we've grown into a large international company. We did have some people sign up for the webinar today from New Zealand, Brazil, Poland, Slovenia. I want to welcome those guys as well. And we've experienced pretty steady growth over the past 4 years. We do this primarily by focusing on 5 key factors. These factors include getting the most out of your material, and that may look like only a couple percentage point, but if you take that out over a year's time period, it turns out to be a significant amount. Also, once we nest the parts, we're going to put the toolpath on the parts, and we're going to optimize the motion to go from part to part, as well as looking at things like pierce reduction, various other accommodations for this. What we're going to focus on today is the manpower side of things, which is importing SolidWorks files, just doing things to eliminate wasted time while programming in the CAM system. And on the management, we'll take a look at, we'll have MRP systems. We'll run that through a product which we call SimTrans, import that information and the work orders into SigmaNEST automatically. And also we do very well at running multiple machines within a facility. In order to accomplish this, we like to position SigmaNEST right in the middle of the fabrication facility. So we'll take input from sales, from the MRP, from engineering, from the sheet inventory, dump the resultant down onto the machines, running multiple machines at the same time, and feed the resultants back into the system and continue this loop. So once we have the parts imported, which I said we're going to focus on, we're going to nest these parts. I mentioned just a little bit ago that a small amount turns out to be a whole lot. In this case, it's only 10 parts on the nest, and on the left-hand nest, seemingly there is no more space to nest parts. But we've created some algorithms to get 10 more parts on that sheet, thus saving 5% scrap. If we could send that out through a week, a month, a year, that does turn out to be a significant amount of material. After the nest is created, we'll put a toolpath on it. We're going to optimize the cut conditions specifically for the machine. We can do some other advanced cutting techniques such as head down rapids. So if we come over a part which it could possibly tip up, we're going to raise the head over. Other than that, if we're going over uncut material, we'll stay head down. We can pre-pierce. We have an eye-pierce routine which will cut an eyelet off the side of the part, take the lead in from the adjacent part, put it into that eyelet, therefore eliminating the need for the pierce. Inventory control turns out to be a very important feature in our system. What we can do in there is keep track of our stock, but what's more is we can do a nonlinear crop at the end of the nest, check that back into our system, and then we can pull that back out. So if we take a look at this next slide, you're going to see this particular remnant right here, whereas if we did a linear crop on that, all that part to the left would be a portion of the sheet we wouldn't be able to use. And like I said, we're talking about 5%. How many parts would be able to fit onto this sheet because we had that extra material to nest on? We're also scalable. We have introductory packages where we can just do CAD nesting and NC programming all the way up to the phase 3 implementations, which is what we're going to be talking about today. MRP integration, PDM integration, importing SolidWorks, importing Siemens, all these other things. In the 2D import, once we start getting into the meat of this, we are going to primarily focus on importing DXF files. We're going to look at techniques of dealing with layer mapping and other concerns that you may have with 2D import. We're also going to talk about, we'll go through a scenario with PDF import, both raster and vector, but I'm going to pause here and discuss this just a little bit. The vector PDF and the raster PDF are actually two separate things, and people seem to be confused on what those are sometimes. A vectorized PDF, you'll see those mostly in engineering drawings. They will have a direction as well as a magnitude. It's a line. When we bring that in, it's going to be that length. And you'll see what we have right here is a sample of what you may see as a vectorized PDF. Converse to that, we have the rasterized PDF, which is a grid of X and Y coordinates. So if we look at the headlight over here on the right, you'll see that those are just little dots. Most people have seen this in a JPEG or BMP image. So we would actually have to assume a line down this row of dots to create this. Once we start assuming that, you can then imagine there's going to be some cleanup work to do on this possibly. But we'll go through a scenario on that. On the 3D import, we're mostly going to use SolidWorks for today, but we do have some wonderful partners with us. Autodesk, Siemens is a very good partner with us. And we're going to look at scenarios of bringing those in through their respective PDM systems. So let's go ahead and get started. Oh, I'm sorry, I forgot a slide. These PDM systems you'll see here is Team Center, Windchill by PTC, Autodesk Vault. And I think that's the last slide before we actually get started there. I'm getting ahead of myself. So we do have integration with MRP systems. These MRP systems will contain all the information such as work orders, materials, and sheet inventory. We'll use our product called SimTrans to take information from that, assign transactions to it, and move that information down to SigmaNEST. That's going to be very exciting to see when we get to that part. So let's go ahead and get started now that we did all the slides, right, Jacob? Let's do a quick poll first. And that is, did you launch that? Okay, let's do a quick poll. What CAD software do you use? SolidWorks, Autodesk, Windchill, Team Center? Go ahead and answer that, and we'll kind of get an idea of the audience here. So it looks like a pretty good split at this point in time between SolidWorks PDM and Autodesk Vault. And there's quite a few who aren't using any PDM right now. So this is a pretty good opportunity to see, for those that have it, how we're going to deal with it, and those that don't have it, kind of what it looks like and what it is. So let's go ahead and close that down and start taking a look at SigmaNEST. We're going to start off fairly simple up front by importing a DXF file. That in and of itself really isn't all that exciting. other than until you don't have what we're about to show, and that is you may only be able to import one DXF file at a time. And SigmaNEST will be able to grab multiple DXFs, bring them in, it will separate them into their own respective parts with material and thickness, bring up the part parameters, and then we'll be ready to go. So right here, you can see right out of the gate, we're able to change the quantity, the material, the thickness. We'll go ahead, and that's our layer mapping screen. We'll address that here in just a bit. That's going to put us into the part parameters where we will assign part names, materials, thicknesses, and other important information. The next one we're going to look at is level mapping, layer level mapping. This is a very sticky thing for fabricators. Many of you guys have these DXF files that come in with these layers similar to this. Some fabricators will save off this as a separate DXF file, delete the information they don't want, and then import that DXF. Versus what we're going to do here where we're suppressing the layers, and then we're going to go ahead and assign the attributes for the processes on the machine. So here on the marking, we're going to choose marking, and the no kerf, we're going to choose no kerf cut. We hit OK. We're back to our part parameters where we were just a few moments ago. That can save a lot of people a lot of time. Let's look at the next DXF file, which is string tags. This could help quite a few people. On the string tags, you're going to see that we have information come up which calls out the part number, the material, the thickness, the quantity, and other information that would be put into the part parameters. If we can attach that, bring that data into the part parameters along with the geometry, that's going to help us get things done a lot more quickly. So you'll see at the top we have 0, 9 through 1, our drawing number, our material, our thickness, as well as our number to nest of 99 that showed up just a few minutes ago. The last one that people struggle with is open contours. Many times a fabricator will import some parts that need to be fixed. And in order to fix them, they have to go back to the CAD system, fix them in the original CAD system, import them back into the CAM system, and then process them. In SigmaNEST, we have an onboard CAD system, which Jacob hit the show errors button, and we have tick marks indicating where our errors are. We're simply going to hit the edit button, use our CAD tools, such as trim extend, and connect the lines. At the bottom right portion here, we're going to use our quick trim. Get rid of that error. On the bottom left, we'll do the same. We'll rebuild our part. We'll hit OK, and then we are back to the part parameters dialog box. Once we're at this part parameters dialog box and we see our part in blue, that's very important color to the SigmaNEST users, that indicates we have a good part. And we're able to take this information, put it down on the workspace, and continue on with the process. Let's go ahead and make up a new workspace, Jacob, and start on the PDF stuff. The first one we're going to look at is the vectorized PDF. And when we bring that in, you're going to see on our layer mapping screen that we have just that. We have layers on this PDF. We can suppress these layers, but we also see that even though layer 0 here has the geometry on it we want to cut, we can use that information that we just covered about going into the geometry, deleting out that extraneous information, that crosshair, rebuilding the part, and we're good to go. We would expect that to be easy. The rasterized PDF is going to be a little bit more difficult as far as the geometry, right? So when we import that, we're going to notice on this circle right here that we have those pixels that you're used to seeing in maybe Paint or some other BMP. SigmaNEST is going to recognize these, assume a circle around that, and there's other, off to the left, we see the vertical line as the left edge of the part. That's going to be easier to create a line on than something that's an arc where the pixels actually deviate from one another as they go around the arc. So as we see, the title block is not in good shape. On the left-hand side, we're seeing it's all on one layer. I can't suppress that. That is a format of the raster PDFs. So we have to use the onboard tools. We can delete off the information we don't want. We're going to keep the part. We're going to get rid of the crosshair here. Here's our part. We hit OK. We're back to our part parameters. We're ready to go. There is a function in there which we failed to show real quick. Let's go ahead and do that, Jacob. I'd rather go ahead and show that because I think it's very important. Give us just a moment to get back to our layer mapping screen and work on this geometry. What we're going to look at while he's processing this is we're able to define a couple points on this part and then scale it to a dimension that we want, because as we bring in this this PDF, this style of PDF, we don't know the size of it versus the vectorized PDF. This rasterized PDF just kind of comes in. So we're going to use the scale by dimension. We're going to choose the top right corner, the top left corner. We're going to make that dimension 10 inches instead of 711. Hit OK. Now we've got the part the size we want it. And I think that's a very important part of this conversation. So you'll see here it's 10.91. That's accommodating for that leftmost portion of the part. Okay, we're going to move more into dealing with 3D products now. So first thing we're going to do is look at a SolidWorks assembly. This particular assembly, we can see some components on the left-hand side, on the right-hand side, along the top, but we also see some bolts up there, and there's some bolts on the front side of that as well. We want to be able to import this assembly without bringing in the bolts. We can't cut the bolts. So in order to do this, we're going to use some of the filters that we have in SigmaNEST, and these things can be put on different manufacturing profiles in order to import this. But also in dealing with the PDM, right now this is checked out so we can view it. We're going to go ahead and check this back in to the PDM and close that model down. So now we have our model checked into our PDM system. We're going to import the SolidWorks assembly from here, and we simply hit import. We have filters that we've created before this. We're going to apply those filters, and you'll see the parts will come listed here on the top. There's our parts right there. And we'll hit OK. You'll see the various materials and thicknesses and quantities that came through. And the parts will show up here on our screen. Right now it's going through, it's separating all the geometry into its individual components, understanding material, understanding thickness, and that's what we have right here. And you can see as he scrolls through it that primarily on this, the thickness is what changes as we bring these parts in. The next that we're going to look at is another SolidWorks assembly. This is going to be pretty interesting I was interested first time I saw it, that this assembly contains a lot of information in here, like multi-body parts. It's going to have structural members, channels, and other toolbox components from SolidWorks. So you'll see that what looks like a key over there on the left-hand side, right there. We don't want that to come in. So we're going to go ahead and check that back in. And we're going to see what this looks like and look at some of the filters in SigmaNEST while we import it. So here's our assembly. We're going to choose our desktop, and we're also going to go over to the SolidWorks tab and choose to filter out the toolbox components. And those components are the ones that we discussed earlier that we just didn't want to bring in. Now we're back to a similar spot. We import our parts with the quantities, the materials, the thicknesses as well. We bring them into SigmaNEST and we're ready to nest. And here they are all listed in our part parameters dialog box. We can continue setting them up. So we spent a lot of time manually bringing in these parts. I want to look and investigate with you some more of the automatic functions that we can do. Can we open up that CSV, Jacob? What we've done here is we've defined some SolidWorks parts, some DXF files, some standard shapes, some SigmaNEST parts that we wanted to bring in. This information is coming seemingly from our MRP or ERP system. We're assigning it transaction types as well as work orders to import. So we're going to close that down, and I'm going to show you something else here in SimTrans. So what we're doing here is running some batch files before and after we process this. So before transaction wall, we'll go ahead and set up the task the way we want it to be set up. And this execute afterwards, the auto task run. These parts that I'm bringing in are different materials. They are different thicknesses. We're automatically going to separate them out into their own tasks. We're going to nest them, and we're going to post them. So Jacob started SimTrans to go ahead and start running. Here's our before transaction .wall, which is doing some preliminary work to the system. And now you're going to see it's going to come through and start running those transactions, importing the SolidWorks parts. Here's our SolidWorks parts. Here's our DXF files that we're importing. And keep in mind, off to the right, we are assigning work order numbers to them. And we've also imported some SigmaNEST parts as well into the system. You're going to see we're going to open up several dialog boxes here posting these things out. So I've actually, on the right-hand side, 13, 14, and 15 and 16.bvl are the resulting NC files. So without touching anything in SigmaNEST, I was able to go import the geometry, assign work orders to them, automatically nest them, post them out, and we're ready to go to the floor. That's about all I had for today. I know we covered an awful lot, but I want to open up the floor to a couple questions. Does anybody have any questions? We've also launched another poll, which is really asking, what would you like to see on your next webinar? Nesting efficiency, more shop floor automation. We do have a 3D product that would contain SigmaTube. We can run a 5-axis laser out of that, or SigmaBend, or more information on motion optimization. So right now we have some pretty interesting results. Nesting efficiency seems to be ahead of shop floor automation only by a little bit. So that just makes me say I'll just do both of them at some point in time, probably over the next month or so. We'll continue to keep you guys in touch with us and email you and let you know when these next webinars are going to be. With that, I do not see any questions coming through. I want to thank you for your time and enjoy your webinar. Contact us if you have any questions. Have a nice day.